Now we'll put input. So the bottom tank or cooling tower basin. So that information we'll put. Let's say elevation is 2 meter. Elevation is 2 meter. Please type the numbers. And pressure model will keep it static. All right. So this is bottom tank. Now, other things will be same. Yes, we'll keep it same.
For tank 1, sir.
Yes, ma'am.
Sir, are you doing it for tank 1, sir? For
The
the
bottom
tank or the top?
Bottom tank.
For the bottom
This
tank.
cooling tower basin. All right. So bottom tank is 2 meter and static pressure. The top tank is 10 meter and static pressure.
So I have to do the second one too. The first tank. Elevation is 10 here.
10 meter.
10 meters. Static pressure. Okay.
All right. So tank data we have already provided. Then let us select all the 3 exchangers. Okay, one by one. Using Shift key.
What is the bottom tank data?
2 meter static pressure. Yes, Mr. Mark, select all the 3 exchangers.
Shifts.
Okay. Now if you yes, already you are selected. So elevation we are going to keep it 0, no change there. There is pressure loss model, right? So there are 3 options. So if you're on standard relationship, then it will actually calculate for the given flow what would be the delta P. Okay, so what input you need to provide? You need to first tell in the shell and tube exchanger, this water is going in tube side or shell side. If it is going in tube side, then what are the number of tubes? Okay, number of tube passes, then tube dia, tube length. So based on this information, it will calculate delta P. If water is going in the shell side, then the input will change. Right? So what is the pitch? What is the tube body? Then the number of baffles, baffle spacing, shell ID. So the actual theoretical calculation it will do. This option is not available in other softwares. If you go for the second option, manufacturer loss data, meaning vendor would tell you for given flow rate, like say 100 meter cube per hour flow rate, what would be the pressure drop? Let us say it is 1 bar. Okay, and the exponent is say 1, meaning it will be linear. If flow rate is 150, then delta P will also be 1.5. In that ratio, it will increase linear.
Okay.
Then the third option is fixed value. Fixed value means whatever may be the flow rate, pressure drop is going to be, let's say, 1 bar. Right?
Yeah.
This is not really a correct way of doing it, but still, in order to keep things simple, we can consider this. So flow rate is 100 meter cube per hour, then also delta P is 1 bar. Flow rate is say 90 meter cube, then also delta P is 1 bar. Then there is the heat loss model. Okay, there are also 3 options. So ignore heat loss and gain means if the inlet temperature of water is 15 degrees C, outlet will also be 15 degrees C. There will be no heat gain or heat loss. If I select fixed temperature change, the first thing we need to give is what temperature change you want. So I'll say 10 degrees C.
10 degrees, okay.
Right, and I need to tell what is the heat transfer direction. So what do you mean by heat transfer direction? If cooling water, if cooling water is getting heated, right? In this case, cooling water temperature is increasing. So heat transfer direction will be out of network or it will be into network?
Into network.
It will be into network because for us water is the network. So heat is going into the network. So we'll select into network. So because of this, when inlet temperature is 15 degrees C, outlet would be 15 plus 10, 25 degrees C,
Okay.
right? Then next is the properties on the flow sheet. So you can click on that, make it show. Yes, so what properties we want, and the alignment we don't want bottom because that will block, overlap the line. We'll go for the left, right?
Yeah.
So here, you click on properties in the input. Expand input. Yes, in input we want pressure loss constant. That 1 bar what you are given, so that we need to give as means in the box. Pressure loss
constant.
constant.
Okay.
And what else we need? Flow rate. But flow rate will not be in input, it will be in results.
So,
You can scroll down.
well,
Scroll down for the results. So that will
okay,
be
I've
flow.
seen it.
Yeah, flow.
Then,
Alright.
okay.
Does it? Yeah. Alright. Let others also complete till this. Okay, so let's assume that we had done the Aspen EDR simulation for these 3 exchanges, and we found out that each of these exchanges need 100 meter cube per hour of water, cooling water, right? Now our pump, we have got 2 pumps there, but one running, one standby. So what will be the capacity of each of the pumps?
That's 300.
100.
It will be
300, but
300.
there are 3 exchanges.
Yes. So click somewhere else, Mr. Mark, and then select both the pumps using Shift key. Yes. Now I said click somewhere else so that you already selected those 3 exchanges, right? So you want to deselect it.
Okay.
All right. So you want to only select pumps now.
Correct. Selected now.
So in the data palette, if you see automatically size, it says off. Make it on. All right. So size
Okay.
of flow is correct. What is the design flow? 300.
Design flow 100.
300.
Sorry, 300.
Okay. Chart 5 RA, here it's -6.
Done.
It's
Now
done.
if you see the second line, it says status. It says on, right? Means
Yeah, on.
it would mean that both the pumps are on, but we don't want both the pumps on. So you can
Okay.
click somewhere else on the flow sheet. Then select only the bottom pump.
Bottom pump.
Yes.
Okay. Looks like the 2 are still selected.
No, you need to select the bottom pump.
That's what I'm trying to do.
Okay, go to
Okay,
input, then
selected.
status, you make it off. Status, instead of on, you make it off.
Off. Okay.
Because if you notice, if you click somewhere, yeah, click somewhere, you see the difference between this running pump and the standby pump, right? So standby pump or inactive items will have this box around it.
Okay. Misunderstood you.
So one of the objective of doing this assignment is to do the line sizing. Correct?
Yeah.
So we need to start with some numbers. So let us select all the pipes together.
All the pipe shipped.
Or we can do this quick way. So if you go to this edit on the top left, there is file edit is there. Click on edit,
Edit.
then select pipe.
Okay.
So this way, usually I wait while you have completed 50% or more, then I tell this, so that you would have more appreciation for this shortcut.
This software is very good. I think I'm going to get it though, honestly. I'm going to get it. 2 weeks. 2 weeks is not good enough.
Okay, so length we are going to change for all the pipes. So length you can change to 2 meter.
The length 2 meter.
Length 2 meter.
Okay, per pipe. Wait.
Each
Length
segment
unit
is
is meter. Length is 2.
2 meter. Then nominal size default is 2 inch. We'll make it 12 inch. Schedule 40.
12 inch.
12 inch. Click on that. 2 inch. You'll see that 3 dots. Click on that. It will open a table. Scroll down. Scroll down. So you'll see that 12 inch is there. You need to expand that 12 inch. Expand it. And scroll little down. Schedule 40 will be there. Yes. Then click OK. Then since it is water system, pressure model will be as and will.
Yeah.
100 as and Williams coefficient.
100. Okay.
All right, that's it. Let others also copy this. So once it is completed, till this point, you please write C in the chat box.
For the heat exchangers, what should be in the input?
Yes, for heat exchangers, okay, I'll open that. So for all three, it is delta P, pressure loss constant is 1 bar, fixed temperature change 10 degrees C into network. And properties also you can check. It is pressure loss constant and flow.
Pressure loss constant. Okay.
So, Madhu ma'am, is it done?
Yeah, it's done.
Yeah.
Yes, sir, I've done it. I'm confused with the flow where we typed the 300 for the pump.
No, as I said, each exchanger, the separate calculation maybe in EDR we have done, and we have found out that we need 100 meter cube per hour cooling water to be sent to each of these exchangers. So the total is 300.
Where should I give that input, sir?
In the pump. So you need to select both the pumps. Then automatically size would be on. Then the design flow 300. That's it. And once you have done that for both the pumps, you want to keep one pump off. So you can keep the bottom pump off. The status, if you see, it is not on. It should be off. Ankur, is it done? Ankur, Vivek. So a lot of radio silence from that side.
Yes, sir. I'm here. I'm traveling.
Okay.
I'm on mobile.
All right.